Good morning. How is everyone doing? Very good. To start with, I think a big round of applause to the organizers. To do something like this requires a lot of effort. Just want to thank everyone who is organizing this to get us all together. My name is Sai. I go by Sai Tadigadapa.
And hi, I'm Nidhi Swamy.
Right. We both work at Capital One. We are part of the marketing and decisioning technology team, and we, over the last few years, we are working on moving from a monolith application to completely cloud-based microservices platform in our credit decisioning space. So today we are here to share our learnings based on our experience, and so that you guys can either add value to the discussion or learn from what we are saying, right? To start with, how many of you have a Capital One credit card? That's a good number. And how many of you know that Capital One is a technology company? Okay. I think hopefully by the end of this session, you all will know that Capital One is a technology company. That's the goal. How many of you are using microservices right now or plan to use microservices in future? All right. So I think this discussion will be relevant for all of you. To start with about Capital One, we are the nation's top 10 bank. We are also in UK and in Canada. In fact, many years ago when I was in Montreal, that day Capital One launched our credit card in Montreal in Canada. We are headquartered in McLean, Virginia. Even though we are well known for our credit card products, you might have seen our ads almost everywhere. We also have auto loans, commercial banking products, and personal banking products like checking accounts and savings accounts. We have been on a path towards becoming a technology leader over the last few years. A big part of that is hiring and growing world-class engineering talent, top engineering talent. Even though we are headquartered in McLean, we also have development centers in Chicago, San Francisco, Plano, Seattle, Richmond, Virginia, and Boston very recently. Very recently we started our development center there. So in addition to hiring laterally, we also hire from the campuses, and we also have a program called CODA, which actually trains software engineers who are not into software, but we have a boot camp we put them through so they become software engineers. So we are hiring aggressively, and if anyone is interested, please let me know. We can have that conversation after this talk is over. Want to mention we also have Capital One Tech College, which is associates, employees can do a lot of courses to learn technology all the way from microservices, Devops, to machine learning, data engineering, whatever it may be. And the other big part of our journey is embracing public cloud. We are migrating almost all our on-prem applications to AWS in a big way. In fact, the platform we support, we are going to be done pretty soon migrating the whole set of capabilities to AWS. In addition to that, we embraced open source technologies. Anything we build mostly is built on open source technologies. And also we contribute a lot to open source. We encourage our developers to contribute a lot, and that's a very good way to engage our engineering talent. In fact, Hygia is our Devops Dashboard. If you guys haven't heard about it, definitely go check on it. Google for Hygia. It's one of the top contributed open source DevOps platforms today. And all this also made possible by our investments in going completely agile across our development, also most of the business teams. We have actually full stack engineers, small teams, typically 5 to 6 engineers with a product owner and scrum master. And that's actually very relevant for the microservices journey I will talk about later. And also we invested a lot in our DevOps infrastructure. We are also moving away from our legacy data technologies to big data, Scala, EMR, things like that, and machine learning in a big way for real-time decisioning. And of course, the topic for today, API and microservices, we have a microservices first approach. Anything we build, we want to build with a microservices architecture approach. So I don't want to spend too much time on the benefit of microservices, but our experience is that microservices really delivered on its promises of starting with small reusable services. These services we built, they are being used across various lines of business in Capital One and also across different product lines. And a lot of that reuse is made enabled by the microservices approach. And also, it enabled us to fail fast. Build a microservice with a small team. We realized probably that's not the right technology, so we can quickly pivot to some other technology. We have done like started with Java, but quickly pivoted to Go or Python. Similarly, containers, we took a Docker first and we went to Kubernetes. That's made possible by microservices because the amount of effort involved in pivoting is much smaller. And tremendous productivity gains as part of this journey. There's a lot of value and power in having a small team of dedicated engineers focused on solving a very defined business problem. That leads to a lot of productivity gains, and it will remove a lot of overhead that's involved in building monolith applications. Of course, all that resulted in significant improved like speed to market in our ability to ship our products. There's a lot of value. So a lot of that, of course, made possible by our investments in DevOps, apart from microservices. To me, DevOps and microservices kind of go together. You can't have antiquated or no DevOps platform and go microservices approach, then it's going to be very difficult. But one thing, the rate of speed at which we are deploying is good. It adds a lot of value, but the number of releases that you make also may increase the number of production incidents. And that is a significant learning that we had that we want to share today. The challenge is how do we sustain this high rate of production deployments, high rate of change, but at the same time ensuring production stability? I think that's the question we had to ask when we are starting on the microservices journey. So that requires work on multiple dimensions. Number one, how do you make sure that the service you're building itself is stable, is resilient? Number two, how do you make sure that the ecosystem of microservices, we'll get into more detail later, that has a lot of dependencies. How do you make sure that that ecosystem as a whole is stable and you can isolate the faults when there is a failure with a microservice and ensure that the failure won't cascade to the rest of the ecosystem? And finally, failures do happen no matter what you do, right? But how do you make sure that you're able to detect a problem quickly as a developer and make sure that you can remediate the problem when you have a failure in the production process? So we took an approach of, we call the failure point analysis when it comes to looking at a particular microservice. We had teams with different levels of maturity in building the microservices. We wanted to elevate the game and kind of standardize across the teams. We developed basically an Excel sheet with a set of best practices across various components, integration, inbound and outbound, and DevOps infrastructure, monitoring, networking, and we don't actually move the data in a batch mode to the lake at all. We continuously stream from our microservices. All the events are continuously streamed. So there's a set of best practices around, how do you make sure that streaming infrastructure is really resilient too. So it could be how do you cache? Are you using the right database tool as the backend? Are you NoSQL or Postgres or whatever it is? How do you make sure that your database is active to the extent possible? And what are the tools you are using for monitoring? So it covers a whole lot of things. And dependencies like, are you dependent on the enterprise Jenkins platform or GitHub when you are deploying into production? So the idea is that you look at every component that could fail in the overall microservice and make sure you take care of everything. So that really elevated the game in terms of our ability to design in such a way that we have less number of failures. The key learnings from this analysis are not very different from what you would see in a monolith actually. So number one, you have to treat your configuration of the environment as code itself. Given that we are in AWS, our infrastructure is basically code. You have to make sure I treat it as code, and all the rigor that you have for your core software, you follow the same process. And the other thing, we'll get into more detail later. When you adopt a microservices approach, there has to be some organizational shift in terms of you build, you own. You can't afford to have a situation where you build 50 microservices and there is a separate development team and a separate production support team. That's going to be very difficult for the production support team. So you have to make sure your developers are up to speed in database tuning and monitoring that normally a DBA will do. You have to make sure your developers are good at that too. And of course, there's things around active-active configuration should be default. And this other thing about microservice, typically when you build a service, you tend to test only for your real-time loads, not for the batch loads. But in reality, you will use the service for both batch and real-time. You have to make sure you test for all those scenarios. And when you go to public cloud, almost every vendor says, okay, it's auto-scaling that's available out of the box, but it takes time for auto-scaling to kick in, right? So capacity planning has to be a continuous process. So these learnings are not very different from what you would see in a monolith, but where it's going to be different is with the dependencies when you have an ecosystem of microservices. So this is actually, I removed the service names. This is a subset of the microservices that we have as part of the decisioning process. One thing you may want to realize here, some of the services you build, so you have a control over its resiliency and stability. But a lot of services you are dependent on other teams. For example, your enterprise teams, that may deal with some enterprise customer stuff, or it could be some external vendors. In our situation, probably it could be credit bureaus, or it may not be your line of business, but you're dependent on some other line of business services. So the thing is, you may not always have control over how they are architected, how they are designed, but without your knowledge, they will be part of the whole chain for fulfilling a particular customer request. So while that architecture itself is complex, the rate of change at which you are deploying puts additional pressure on those dependencies, right? The architecture changes as we build. When you are in agile microservices world, in DevOps world, and every release you may add a new dependency to the picture I showed here, right? Or one of the dependencies may change. You are consuming some other service, their contract may change. So you run into those kind of situations which puts additional pressure on the systems that you are supporting. And you think you can manage this change with complete automation, right, with your DevOps pipeline and everything. But that will be a moving target. You can still, probably you can't really avoid situations where a developer may go and make some change manually. Not really manual, but they may make some change which is outside of the DevOps pipeline. So the overall configuration of the environment keeps changing in this complex environment. So how do you deal with that? So to build resiliency for that kind of environment, it actually starts with your design and architecture. Your first goal should be how do you isolate the fault when your service fails, right? Second thing is, when that fails, how do you make sure the other services downstream also don't fail, right? For example, for any customer order, finally you book the order, right? You have a service for the order. But when that order fails, probably you have some upstream rules engine, a pricing engine, for example, that will still fail, right? If the booking service fails, because you can't accept any more applications from the customer. And so you need to think about how do you prevent the cascading failures in the microservices ecosystem. And finally, the most important thing is when you are building microservice, you have to treat the other services that consume your service as a consumer, as a customer. And that a whole lot of culture shift, whole lot of changes that you have to make in the way you define your SLAs. We'll get into more details later. The first thing is I think there was a session on domain-driven design as part of this conference. One important learning for us is you have to make sure that the services are as decoupled as possible. For example, you want to make sure your decisioning engine has no tight coupling with system that receives the application, right? What happens if there is this tight coupling? Anytime you make a production release, it will require a lot of coordination. Imagine just having 50 teams, being on this release management call, talking about what is the sequence in which you want to go. That will be very, very difficult to manage. And of course, the cascading failure we talked about, once the service fails, it could bring the whole system down. So you have to leverage domain-driven design very extensively to make sure there's as little coupling as possible. That's going to be very important. Normally, we focus on domain-driven design as an architecture principle instead of improving the speed at which you develop. But the same principles apply to the situation when you are actually supporting the services once they are in production. So how do you isolate faults using domain-driven design? Number one, you have to make sure that the service you are defining has a very clearly defined bounded context. And how do you get there? Honestly, that requires some iterations to get there. You build a group of services, you realize probably there is too much tight coupling. You realize probably that this logic shouldn't be here, and it should go to this service. And you have to be prepared for those kind of iterations when you are building, right? And ensuring that the service is the right granularity. Again, it's more of an art than a science to define the granularity. You have to make sure it's not too big, service is not too big, it's not too small. And keeping the domain simple is also very important when you're actually supporting in a production call. You have to make sure that the developer who is supporting it understands what the service does very well, right? And autonomy is the most important thing. When you are designing, make sure that the service is testable on its own and it can be deployable on its own without any dependencies. You shouldn't be ever in a situation where before I deploy this particular service into production, I have to make sure this version of the other microservices also needs to be deployed. If you don't have that autonomy, it's going to be very, very difficult to manage it in the production environment. Now, Nidhi will take over and talk about some of the other architecture principles that you want to keep in mind.
Okay, great. So thank you, Sai, for covering the domain-driven design as well as the failure point analysis. So now let's talk about how microservices actually come together and how they actually interact within your platform. So one of the architectural designs that we use at Capital One is called event-driven architecture. So what does this mean exactly? Event-driven architecture is essentially led by your business and product teams, and when you're making a production deployment, you want to comply to certain events which you end up releasing within your CI/CD pipeline. So as we can see here, we have 4 different microservices which are waiting in our queuing system. But if service 2 and service 3 are interdependent and service 3 needs to wait for service 2, for example, we would need to have that flow, currently processed within our workflow for the platform. So we refactored to asynchronous integration patterns to solve for problems, to ensure that the tight coupling and single points of failures are identified almost immediately, otherwise it can get messy while trying to interact with the different microservices. You also want to be able to have several tasks perform in parallel. This is pretty crucial because you're trying to maximize your efficiency inside your microservice platform. And this comes to our third statement where services are completely or should be decoupled from each other. You don't want to have one service be dependent on another one if you don't have specific timeouts or requirements coming in from your workflow. And decoupling microservices are the goal since you're trying to make sure you have separate unit tests and integration tests which are currently being conformed in your platform. So the ultimate goal in terms of any business application is to make sure you minimize your customer impact. And you want to be able to reduce much of the blast radius in case of a failure. So how do we go about doing this? Well, the first thing you can do is set a timeout. So in this example, let's say you have an orange microservice and the brown microservice in turn is dependent upon that. If there's a timeout error being thrown, then you know that either it's a critical node or a non-critical node, and in terms of a workflow, you'll be able to tell whether or not you can continue on without this orange microservice being decisioned in real time, or we want to be able to retry the logic in case it was a one-time network latency issue. So as we can see here, you have 2 attempts. Attempt 1 clearly failed in this case. And so you want to be able to make sure that attempt 2 is given a shot because it could have been an east to west latency issue, and you want to be able to make sure you're minimizing your customer impact as much as possible. So now let's talk about how to implement circuit breakers. So an example I like to think about is opening up a web page on Google Chrome, for example, and the web page is taking a really long time to come up. So what is the very first instinctual reaction you have to this? You would probably hit the refresh button, right? But that may not always be the best mode of action to take because you end up sending more requests to your particular service. And as a result, a lot of these requests get backed up. And if you open up a circuit breaker, for example, you would be able to immediately let your client know that, hey, look, we know we have an error and we are actively trying to fix it, but we don't want you to keep sending more requests to our service because we are currently getting backed up. And so multiple requests coming in, having a circuit breaker open, lets you have a row of cascading failures happening very quickly in real time. And finally, you want to be able to throw exceptions based on what kind of configuration you've set in your microservice. So there are several exceptions which can happen: internal server error, a bad request where your request body is not correctly configured to your microservice. But for example, in this example, the orange microservice has an exception thrown. And we want to ensure that the other microservices are aware of exactly what kind of exception was thrown so that we can continue on with the platform in real time. So now that we talked about how we want to minimize customer impact, what does that mean exactly in terms of business requirements as well as product decisions? Well, we want to define or upgrade service level agreements, keeping the customer experience in mind. This essentially means that we are running application performance tests, not just within our microservice, but within the platform's microservices. And let's say the business requirement says we need a response from your entire platform over a period of 2 seconds. Well, that doesn't mean your microservice can take 2 seconds. It can take maybe 300 milliseconds or 500 milliseconds. And so you need to work with your other microservices inside your platform to essentially confer to your overall platform goals. So when we're thinking about minimizing customer impact, how do we go about doing this? Well, when we were thinking at Capital One, we came up with a set of questions which basically let us develop a neat platform so that we can adhere to some of the business rules which come in. For example, was the timeout configured correctly? We did talk a little bit about how to throw a timeout, but we need to ensure that the timeout is being set by the gateway and our client, as a result, times out and says, we received a timeout client connection exception. Was there a change in your service? And when there is a change to your service, are you communicating this with your dependencies? This is probably one of the most crucial questions you can ask yourself because there are two kinds of changes which can be made to your dependencies. One is a critical change where you make a breaking version change, and another is a non-critical change where it's just a smaller change where you don't need to exactly increase your version, but maybe the decimal point after. And without letting your dependencies know what changes you have made can lead to several failures throughout your entire platform, which can essentially lead to a bad customer experience. Will a degraded mode work in case of a failure? So in this example, we can see that there is a front-end application, and let's say we just made a new deployment and we have buggy code in our product master. As a result, we don't want to get impeded because of this, and so we would be able to receive information from our product master cache if some sort of decisioning very similar to this had occurred in the past. And this is a really great way to, we'll talk about deployments and Canary a little later, but this is a great way to retrieve information which has already been stored in your data store. And finally, will the fault cascade down the line? This essentially says, if one of my critical microservices fails, do I skip over the other microservices? And in turn, what happens when I send the response back up to my user? So you need to really identify all your hard dependencies just to ensure that you know exactly what to skip and when to skip it. So we did talk a little bit about how to go about making version changes and what that means, either a breaking change or a non-breaking change. But these three fields, I think, are very important when it comes to developing any microservice. One is backwards compatibility. I think backwards compatibility is extremely crucial so that you are not an impediment to the dependencies who are relying on you. And if you are making a big breaking change, for example, and your dependencies have not reached that stage yet, they would still be able to use an older version of your code, which is currently configured inside your microservice. You also want to enable a self-serviceable mocking solution, and this essentially entails owning your own mocking infrastructure. On my team, we've seen several examples where our dependencies mocking instances have gone down, either infrastructure related or their own calls are failing, but because we ourselves do not own those, they are essentially impeding us from meeting like several business deadlines. And so what we did was we incorporated our own self-serviceable mocking solution where we essentially create a mocked cluster of instances of our dependencies. So we own that infrastructure. If it goes down, we can bring it back up. And for all of the different test cases that we own, we would be able to configure it ourselves without bringing another team in. And finally, feature toggles. So you do not want to overcomplicate feature toggles because it can definitely become overbearing. I think having a specific deadline on when I want to decommission features in terms of a new deployment or having a specific client call these features is very crucial as well. So proper testing and controlling environment drift are critical to managing change. Typically at Capital One, when we're trying to test out our microservice, we have a dev, a pre-prod or QA environment, and then finally our production environment. And typically, we want to make sure our dev and pre-prod environments are a clone or nearly mirroring production so that we ensure all our test cases pass in a specific amount of time. We also have bots running so that we know when our infrastructure goes down or when our health checks are failing, and we immediately bring it back up to whoever is depending on our service to be up. We also have a really great test of automated testing where we run end-to-end tests. And typically, each microservice owns its acceptance test-driven development. And as a result, if every team or microservice owns their own testing suite, you'll be able to conform to the entire platform's testing suite with great efficiency. So now that we've gone over failure point analysis and dependency analysis, how do we go about reducing the mean time to detect these errors and the mean time to repair? So we want to minimize our deployment failures by using great deployment patterns to ensure that our infrastructure and CI/CD pipelines are at the tip of the iceberg. You cannot go wrong with it at all. So one such example is a Bluegreen deployment. So what exactly is a Bluegreen deployment? Well, we essentially have dev, production, and pre-production environments, but we actually have 2 stacks in each environment. So let's say in this example, we have an active stack, which is the blue environment, and an inactive stack, which is the green environment. So currently, all of our production traffic, 100% of it, is going to this blue stack. And nothing is currently going to this green inactive stack. So when we make a new deployment, we would actually end up releasing to the inactive stack so that we have a stable active stack in order for any rollback or errors which come up in production. So from Bluegreen deployment, if you want to go one step further, you can take it to Canary Releases. So the main difference between Canary Releases and Bluegreen deployments are you can send a specific amount of traffic to this new stack which you're currently releasing to. So in our case, if we are releasing to the blue stack, we'll send just 10% of production traffic to it to ensure stability, to make sure that things are looking great, and 90% to our current green stack, which was taking 100% of traffic just before this new deployment. This has really helped our team, because we have seen several production failures where we haven't been able to roll back immediately or debug immediately. And so just sending 10% of traffic to the new stack enables you to identify your failures in real time without experiencing or compromising on your customer experience. And finally, you want to have automated Canary rollbacks. So if you have buggy code in your unhealthy stack, you clearly do not want to be sending any traffic to it, not 1%, definitely not 10%. So what our team did was we ended up routing traffic completely 100% back to our healthy stack by enabling a feature called automated Canary rollbacks. In case you don't know how long it's going to take to debug your production code, which you clearly know has a big error to it, and without compromising on customer results, you'll be able to reroute 100% of traffic to your healthy stack because you still have both stacks in your production environment. So now that we've talked a little bit about what it means to release and what it means to deploy, we also want to make sure we are logging and monitoring as well as possible. So what does logging and monitoring mean? Well, there are several types of logging and monitoring strategies which a microservice can utilize. One is system health monitoring. This is a basic health check, making sure your infrastructure is up and your health check for your microservice is working. Application performance management is very crucial in order to track scalability and ensure that your application is performing at its most ideal level by auto-scaling and ensuring that your performance throughout the traffic being brought into your microservice is 100%. You also want to enable end-user monitoring and business activity monitoring. So these two are correlated in the sense that you want to make sure your microservice is conforming to the overall platform goals. And you are experiencing monitoring by getting logs to whatever service you choose to utilize. And finally, recently, Capital One was able to incorporate data monitoring. What this means is we incorporated a streaming data platform where we write all of our logs as well as our response bodies back to a data lake so that any microservice running inside this platform would be able to grab it from the same location. And these 5 essentially go into a bigger log management system where you would be able to create your own dashboards, view your own metrics, and you would be able to get alerted in real time when something is not looking like it's supposed to be looking. So after you are working towards minimizing your customer experiences, the next biggest goal is to actually improve your overall developer productivity. So moving from a monolithic framework to a microservice framework essentially says, I am going to compartmentalize all of my features into individual units so that I would be able to bring all of those together into one bigger platform. So we talked a little bit about logs, ingestion, visualization, where you'll be able to see a dashboard configured with all your microservices, hopefully with your platform microservices as well. You also want application performance management and distributed tracing so that you would be able to trace from the very beginning to the very end whatever happened throughout your workflow. And finally, infrastructure monitoring. So infrastructure monitoring is extremely crucial because without your infrastructure, you would not be able to run your application at all. If you're getting a 503 or an internal server error, you're essentially saying, well, the backend is unavailable, so I can't even run the application. So having monitoring for your infrastructure with whatever tool you use is extremely crucial in order to track your application or microservice health. And finally, the golden signals are latency. How long does it take for the microservice within the platform to run? What kind of traffic are you getting? Errors and saturation, which is happening between your different platforms and microservices. So now Sai is going to talk about improving resiliency.
So to summarize, the work, when you build a microservices platform, you need to work on several dimensions. Number one, you will automatically adopt a you build your own culture. That means you need to upskill your developers, not just for the development, the programming language they're coding, but also overall DevOps and database configuration, performance management, the whole stack. I think our experience is it's really successful when you have full stack engineers. Also, it requires a change in the mindset in terms of treating the consuming services around you as your own customers, in terms of the SLAs and asking the right questions that Nidhi talked about in terms of the timeout configuration, whether it's a hard dependency or a soft dependency, that kind of a thing. That's a huge mindset shift in terms of looking at the services around you. And certain things you need to adopt in terms of design practices that you don't necessarily worry about in a monolith. Things like domain-driven design, event-driven architecture, a lot of investments you make in monitoring and alerting across microservices like dashboards, they're all going to be important. And as I mentioned in the presentation, you have to make sure your key environment is very stable so you're able to test throughout across all the microservices. You have to invest in your testing frameworks, the mocking frameworks that Nidhi talked about, having a very good, robust DevOps pipeline with things like Bluegreen deployments, Canary Releases, automated rollbacks, automated failover, all those things built in. That's extremely important in being able to support a microservices environment in production. Any questions? How are you doing on time? Yeah, I don't think we have a camera. Probably you need to come to the camera.
Yeah, no, I don't have any questions. But
Yeah.
I can be your room moderator from now on. So at the enterprise level, when there are so many changes going on different interrelated microservices, so how did you manage those changes, and how did you incorporate those changes in your microservices or communicate it to those other teams? Because we have to stick to our timelines as well. So how did you guys manage?
Right. There's no one answer for that. I think from a team interaction perspective, the golden rule is you have to design your microservices in such a way that teams don't have to talk to each other every day. So I think defining the right contracts, the version management, backward compatibility, all those things are very important. And also that leads to the productivity gains that we talked about. That's number one. Number two, having the right practices in place, particularly large enterprises, having the Confluence site, and if you're using a developer exchange, making sure the contracts are updated regularly, you have a mechanism to communicate releases, major version changes versus minor version changes, making sure that the minor versions don't break your consuming APIs, and communicate when there is a major version. So what is changing and what they may have to change in case they may have to change. All those things are very important.
I think another thing which I have seen is we'll have to request access to the new version. So without having that inside your pipeline, without consuming the new version or without requesting access, you wouldn't even be able to consume those breaking changes without going through your microservice.
Good question.
Can you talk a little more about how you implemented distributed tracing across your event-driven architecture?
Yeah, you want to talk about it? Okay. I can briefly talk about the technology options available for you. If you are using AWS, they have this tool called AWS X-Ray. And similarly, a lot of APM tools have distributed tracing enabled. So you could leverage that. That's the other option. New Relic has it. You could use that, right? And similarly, if you are using open source like Elk Stack, then you could enable distributed tracing as part of capturing the logs, right? That's the other option. So it depends on your use case, but there are a lot of options available. A lot of APM tools support distributed tracing nowadays.
I think another thing we did was enable it within our pipeline. So we have a server running within our instances, and that in turn creates the logs for distributed tracing to go into a bigger dashboard. So we can see several other microservices and not just us, and how it reacts to a specific application coming in at Capital One.
Let's thank our speakers and take further questions in the lunch break.
Okay. Thank you.